Okay, algebra, part 2, 21 through the end. I think it goes to 40. Number 21, the function h is a quadratic function whose graph is a translation 4 units left, 6 units up of the parent function, f of x equals x squared. What is the equation of x, or of h, in vertex form and in standard form? All right, so we have our parent, and we're going to move it 4 units left and 6 units up. So that would put its vertex at -4, 6. And when it doesn't say, because in this problem above we had to find a, well, it doesn't say anything about, the only translation that's happening is left and up. It doesn't say anything about stretching or compressing. So we just go with a being 1, like in the parent function. Okay, so we're going to start with vertex form. Y, or actually they called it h, so h of x is equal to opposite same, x plus 4 plus 6. So this is vertex form, and to get this into standard form, we would multiply out our binomial squared and then combine all the like terms. Multiplying out x plus 4 squared. Remember, something squared means that thing times itself. So that would be x squared plus 4x plus 4x plus 16, and then the plus 6 on the end. And combining our like terms, h of x is equal to x squared plus 8x plus 22. And that's it for that one. Number 22, what is the equation in standard form of a parabola that contains the following points? Oh, Jiminy Christmas. We didn't do this in class. I need to think about this one for a minute, so I'm going to skip that one, and you can skip it too if I end up skipping it forever, and move on to the next one, and I'll come back to that after I think about it. What are the vertex and axis of symmetry of the equation? All right, it's in standard form, so to find the vertex, we start by finding the axis of symmetry, which is, we have our formula, x equals the opposite of b over 2a. So for this equation, our b value is -8, so we'd write positive 8 over 2 times -3. That'd be 8 over -6, and I can reduce that fraction. Oops, I wrote 8 again. I can divide by 2, so -4/3. Now that's going to be a pain to plug in, but it is what it is. So our x value is -4/3 for our vertex, and to find the y value, we have to plug that into the x's. So that would be -3 times -4/3. My pen isn't working very well here. -4/3 squared minus 8 times -4/3 plus 1. All right, squaring, we get 16/9. We're multiplying that by -3. I can do some canceling. 3 goes into itself once, into 9 3 times. So that'd be -16/3. And then this chunk 3 doesn't go into 8, so I'm just going to multiply. That gives us negative times negative is a positive, so plus 32 thirds, plus 1, which I'm going to write as 3 thirds since all my denominators are in threes. And then we have negative 16 plus 32 plus 3. Negative 16 plus 32 is 16. 16 plus 3 is 19. 19 thirds for our y value. And what did we want? The axis of symmetry is x equals negative 4 thirds. Sometimes you guys forget to put the x equals and just write negative 4 thirds. The axis of symmetry is a line. Lines have an equation, so you have to include that x equals. And vertex. What are the vertex? And our vertex. And that's that. What is the expression in factored form? We've got a quadratic trinomial, the easier kind because a is equal to 1. So I need two numbers that multiply to 12 that add to negative 8. That would be a minus 6 and a minus 2. X minus 6 times x minus 2. And I've noticed when working with you guys individually, a lot of people forget that to check your factoring, multiply your answer back out to see if you get the problem. That's a sure way to check your work. X times x is x squared. Outside, inside, last. Negative 2x minus 6x is negative 8x. So that tells us we did it correctly. Especially on the harder ones. Factored form. So this would be an example. And this had a little typo. That was supposed to be 6x squared. So this is an example of a harder one because our a is bigger than 1. So what we have to do is multiply 6 times negative 4. A times c is negative 24. And negative 5 is our b value. Two numbers that multiply to negative 24 that add to negative 5. That would be a negative 8 and a positive 3. So this takes a couple of steps, and I think maybe, I don't know what I was going to say. So starting out, x minus 8, x plus 3, but whatever our a value is, we have to divide that. Now, the thing to remember is, if it divides out evenly, you're good. Say one of them had been 12. 12 over 6 is 2. So it'd just be x minus 2 or x plus 2. But if the fractions are simplifiable, you need to do that. Otherwise, your numbers would be too big. So sometimes I would get a student that just forgets that part and writes 6x minus 8, 6x plus 3. But this is wrong, because those fractions can be simplified. And we know it's wrong because look at, if we go to check our work and FOIL this back out, 6x times 6x is 36x, and it needs, our first term needs to be a 6, and our last terms don't work either. So it's all about that simplifying the fractions. 8 over 6 is 4 over 3. I'm cutting each of those numbers in half. So just rewriting this. And 3 over 6 is 1/2. And now I'm going to convert it by putting those denominators in front of the x. 3x minus 4 times 2x plus 1. And now I'm going to check my work. Does it FOIL to give you the problem? 3x times 2x is 6x squared. Outside is plus 3x. Inside is minus 8x. Last is minus 4. 3x minus 8x is negative 5x. Our front term is right. Our last term is right. We are good to go. Always, always go back and multiply it out to see. I wanted to show, because some kids learned how to do these problems a different way, and I noticed some people, again, when I was working individually. So I just want to do it the other way that some people might like better. So once you come up with your two numbers in the x, what we could do is rewrite the original, and instead of writing negative 5x, I'm going to replace negative 5x with those two numbers that we came up with, negative 8x plus 3. So my first term, 6x squared, minus 8x plus 3x, and then our last term is negative 4. So we've just rewritten that middle term with two terms. Negative 5x plus 3x is negative 5x. So then what we can do is, now look at this, it has four terms. So this is a factor by grouping problem. I group the first two together, take out the GCF. Let's see, we can take out a 2x, and then inside our parentheses we would have 3x minus 4. Check it. 2x times 3x is 6x squared, yes. 2x times minus 4 is minus 8x, yes. Now move on to the next one. I'm going to look at that guy. And there's nothing to factor out. It doesn't have a GCF. So when that happens, it means you're factoring out a 1. Because 1 times anything is itself. And you need there to be a number in front there. And so we always end up, when we're factor by grouping, the binomial that's shared, so those inside the parentheses will be the same. So that is one binomial in your answer. We're factoring that out. So that makes our second binomial be the 2x plus 1. Again, you'd want to FOIL this out to check, but we already FOILed it to check, so we know we're good. So this way, doing it this way is called factor by grouping. And the good thing about this way is that you also need to know how to factor by grouping when the problems have four terms. So it's also practice doing that one. All right, we have our i's, imaginary numbers. Simplify the expression. This one is an addition problem. So I'm just going to look for my like terms. 3 plus 6 is 9. 2i plus negative 7i is minus 5i. And that's it on that one. And remember, you've got to, they always have to be in a plus bi form, meaning your real number always comes first, your imaginary second. I would not write this negative 5i plus 9. This is a multiplication problem with a little extra parentheses in there on accident. So we've got a binomial times a binomial. This is just a FOIL, or distribute twice. 3 times negative 1 is negative 3. Outside, 3 times 6i is 18i. Inside, negative 2i times negative 1, positive 2i. And last, negative 2i times 6i, negative 12i squared. And whenever you're dealing with imaginary numbers, we have to remember that I squared is equal to -1. So if we ever end up with an I squared, we've got to replace that with a -1. And this last term here has an I squared. So that last term would be -12 times -1, and that would of course be +12. Now I can combine my like terms. Our real numbers first. -3 plus 12 is 9. 18i plus 2i is plus 20i. A plus bi form. And then we have our division in the form of a fraction with imaginary numbers. So the deal with these is we don't want to have there be an I on the bottom of a fraction. So what we do is multiply the top and the bottom by the conjugate. The conjugate is the same thing but opposite sign in the middle. So instead of a minus, it's going to be a plus. And we do that to the top and the bottom because we are just, something over itself is 1. So essentially we're just multiplying by 1. But we're doing it to get rid of the I from being on the bottom. This is no different than you getting a common denominator. Say I was working with the fraction 3/4, and if I needed a denominator of 8, I would multiply the top and the bottom by 2, 6/8. 3/4 is equal to 6/8. They have the same value, it's just in a different form. So we're taking this fraction with the imaginary numbers and putting it in a different form. All right, now we're going to multiply straight across. I'm going to wrap those in parentheses so that I remember that this is a FOIL, since we have a binomial times a binomial on the top and the bottom. So working on the top, 2 times 3 is 6. Outside is plus 4i. Inside is plus 3i. Last is plus 2i squared. And ooh, I didn't mean to do that. No, I don't want to stop recording. Please say it doesn't do that. Oh, I've had so many tech issues. I really hope this didn't stop recording. It looks like it is, but last time I had major issues, so fingers crossed. I am gonna leave that and we'll simplify that in a minute. I'm gonna move on to the bottom and foiling the bottom. 3 times 3 is 9. And I'll go ahead and write out the whole FOIL. But the whole reason we do this is because our outside and our inside are going to cancel. That's what conjugates do when you multiply them, to get rid of the i's. So outside is plus 6i. Inside is minus 6i. And last, negative 2i times positive 2i, negative 4i squared. Now let's work on simplifying the top and the bottom. That I squared, again, we have to fix that. So this would be plus 2 times negative 1, which would be a minus 2. So our like terms on top, real numbers, 6 minus 2 is 4. And our imaginary numbers, plus 7i. And now on to the bottom, the I squared again. So this last term would be negative 4 times negative 1, which is a plus 4. Real numbers, 9 plus 4 is 13. And again, our outside and inside canceled. They add to 0. And then we're done at this point. When all three of the numbers can be divided by something, then you can do that. Divide all three, but it has to be all three. And 7 and 13 are both prime, so there's nothing else to do on that one. And then there wasn't, let me check the next page. Yeah, there wasn't an example of a fraction with just a monomial on the bottom. So I'm just going to throw one in real quick. Say it was 5 over 3i. So our bottom, or I'll make the top a binomial. 5 minus 2i over 3i. So our bottom is just a monomial. When the bottom, so we use the conjugate because it was a binomial. When the bottom is a monomial, all we have to do is multiply the top and the bottom by I. That will get rid of the I from being on the bottom, since we end up with an I times I, which is I squared, which is -1. On the top, if we multiply a binomial times a monomial, that's a distribute. It looks funny because the i's on the right-hand side, but that would still be a distribute. I times 5 is 5i minus 2i squared. Again, I'll simplify in a minute. On the bottom, 3i times I, 3i squared. Now let's simplify. -2 times -1 is +2. So on top we have 2 plus 5i. Remember, I'm not going to write 5i plus 2 to have the real number first, imaginary second. And on the bottom, 3 times -1 is -3. All right, 29. Find the solutions of the equation. We've got a quadratic, and so first thing that's standing out to me is that a value is a fraction. When we're dealing with an equation, there's two sides. We've got our equal sign and there's two sides. So I can just get rid of that fraction by multiplying both sides by the denominator 2. Because 2 times 1/2 is 1. So we have 1x squared, or x squared, minus 2x minus 8 equals 0 times 2 is 0. So we just cleared it of the fractions. This makes this a lot more manageable. So I'm going to check to see if it factors. If it doesn't factor, I can use either the quadratic formula or completing the square. But it turns out it does factor, so we are in luck. That's the easiest. Sometimes they don't factor though. Two numbers that multiply to -8 that add to -2, -4, and a +2. Again, FOIL it out to check your work. X times x is x squared. Plus 2x minus 4x is minus 2x. -4 times 2, -8. All right. Once we factor it, now we set each factor equal to 0. And I want to point that out too. Sometimes I'm getting students still messing up when the problem says factor, there's no equal sign. So you just factor. We're done. I'm getting some students on the quizzes and stuff still trying to do this and then solving it. You can't solve something that doesn't have an equal sign. This isn't equal to anything, so we can't solve it. Our directions were just factor that guy. Versus when there's an equal sign, you're solving, finding the solutions. All right, so we take each factor and set them equal to 0. X minus 4 equals 0, and x plus 2 equals 0. So solve each equation, 4 and -2. Okay, that's it. Rewrite the equation in vertex form. Name the vertex and the y-intercept. We've got it in standard form. So to put into vertex form, we use completing the square. So I don't need the c value right now. So I'm going to minus 7 both sides. And now I can find that magic number. I take half of 6 is 3, and I square it. 3 squared is 9. So we're going to add 9 to both sides of our equation. Y plus 2, negative 7 plus 9 is 2. And this side now is a perfect square trinomial. When I factor it, it looks like this, x minus 3 squared, quantity squared. And now I'm just going to throw the minus the 2 over. So y is equal to x minus 3 squared minus 2. Write the equation in vertex form. Here it is in vertex form. Name the vertex. Vertex is 3, negative 2. Opposite, same. And name the y-intercept. The y-intercept is easy to find when it's in standard form. That's our y-intercept. It's always the c value. Because your y-intercept is where it's crossing the y-axis. So the x value is always 0. So if you plug in the x's as zeros, y equals whatever number that is. So our y-intercept is, and I can write just 7, or I could write it as an ordered pair, 0, 7. Either is fine. Use substitution to solve the linear quadratic system of equations. All right, so we've got y is equal to this quadratic, and y is equal to this linear. So I'm going to take what y is equal to in the top equation, and I'm going to substitute it into the y in the bottom equation. So we're taking this guy and we're writing it in the y's place. So rewriting this guy, x squared minus 4x plus 7 is equal to 2x minus 1. Now we're going to get everything on one side to solve this quadratic equation. I'm going to subtract 2x both sides, and I'm going to add 1 to both sides. Now there's nothing, 0 on the right hand side. Our left hand side, x squared minus 6x plus 8. Quadratic trinomial, so I'm going to factor it to solve. And negative 4 and a negative 2. So solving for x, x minus 4 equals 0, x minus 2 equals 0. So x is 4 and x is 2. Now remember what we're doing, big picture here. We're solving a system of a parabola and a line. So we're looking for 2 ordered pairs to be our answer. I know there's 2 because I got 2 x's. Remember what it could also be if the line is crossing through the vertex, then there would just be one answer. But that would have, over here, we would have just had one answer. An example of that would be like if both your binomials said, if it was x minus 4 times x minus 4, then x equals 4. That would be your one answer. But we do have 2. So when x is 4, I'm going to come back over. I can use either equation, but it's easier to plug into the linear one to just make the calculations easier or faster. So when I plug in the x as a 4, we have 2 times 4 minus 1. 8 minus 1 is 7. And then our other answer, when x is 2, 2 times 2 minus 1, 4 minus 1 is 3. 32. Which system of inequalities is graphed below? Okay, so we've got a parabola and a line, and it's shaded, kind of some funky shading happening in here, but obviously it meant to be shaded. Below the line and above the parabola. Above the parabola and below the line. So we have to write our system. Let's do the line first. Lines, y equals mx plus b, and I know this is hard because of that shading. Is this graph going by 2's? No. I'm just having a hard time reading this graph, where it starts. If this is -8, 6, 4, 2. Yeah, it looks like it's going by 2's. 2, 4, 6, 8, 10, 12, 14, 16. Because of the way this shaded, it's all dark, so it's hard to read that. But over on the x-axis, 8, 9, 10, 11, 12. So I hate when they do that. You got to really pay attention to your axes. So our y-axis is going by 2's, but our x-axis is going by 1's. So we're going to have to be really careful writing our equation here. Okay, so 2, 4, 6, 8. So it looks like it's crossing through 7. Our y-intercept is 7. And now we've got to figure out that slope. It's going through there. And it's like you're trying to find that exact point. I can't tell if that one, but I feel like that one looks like it is. If this is a question on the final, it's not going to be all messed up, a graph like this. It'll be much more clear. So please be aware of that. So rise over run. I know it's a negative slope. Little man's walking downhill. We're rising. Remember, we're going by 2's here. So that'd be 2 and then 3. And then our x-axis is going by regular 1's. 1, 2, 3. Oh, so it was going over. So -1 slope. 3 over 3 is 1, and it's negative. So our slope is -1. So our equation for the line, y equals -x plus 7. Now we need an equation for the parabola. We need the vertex, which looks like it's in between two numbers. This our x-axis is going by 1's. 1, 2, 3.5. Ugh. So that would be 7/2 is our x value of the vertex, and it is down 16, 18, 20. And the a value, see, they're making this too hard with this dumb graph. I apologize. This should have been fixed so it was much more clear. I'm just thinking of, I wonder if there's, instead of using vertex form, what if we used the intercepts? I wonder if we'd get the same answer. Because I can see we're crossing, this looks like 0. I don't know why that doesn't look like it says -2. Wait, that'd be -1, wouldn't it? If this is our axis, -1, -2, -3, -4. So it looks like we're crossing, we got a root, a solution, a 0 at -1 and 1 at +8. So take your brain back to chapter 2 And if those are my roots, my factors would be x plus 1 times x minus 8. And I'm just going to assume a is 1 because this is a bad picture. So we could FOIL that out so it's in standard form. It doesn't say it has to be in a form. So if I was grading this test, I would accept leaving it in factored form. But if it told you to answer in standard form, we just FOIL that out. X squared, outside is minus 8x, inside is plus x, so that'd be minus 7x, and then last is minus 8. And that does line up. Look, that's our y-intercept, and it does work out. So I feel like using the intercepts was a nice, cleaner way than to try to use the vertex. And that's our system. 35, simplify the sum. This is an addition problem. So I've just got to look for like terms. Start with the largest exponent. 5x to the third doesn't have any x to the thirds to add it to. X squared comes next. Negative 2 plus 4 plus 2x squared. And then our x terms, there's only one, minus 6x. And then our constants, 8 plus negative 5 is plus 3. Nice, easy addition problem. Multiply, you guys know this well. This would be a FOIL, or distribute twice. First terms, 18x squared. Outside is minus 12x. Inside is plus 15x. Combining those like terms gives us a plus 3x. And last is a minus 10. Factor. All right, so 2 terms. So very first thing I do is look for a GCF. And what can we take out? Well, 77 is 7 times 11. And I can divide 56 by 7, because 7 times 8 is 56. So we're going to take out a 7. And then when you have 2 x's with different exponents, you take out the largest that you can. So that'd be the x to the third. So we're undistributing. 7x to the third times 8x squared gives us 56x to the fifth, minus 7x to the third times 11 is 77x to the third. And looking inside here, that is prime. You always got to look inside. Will it factor? It won't factor, so we're done. That was just a undistribute problem. Take out the GCF. Use the polynomial identities to multiply. Okay, so this is a binomial to a power. So you could either multiply it out, 5r minus 2 times 5r minus 2, multiply 2 of them, get your answer, and then multiply by the third one. Or we could use Pascal's triangle. So I think I'm going to use Pascal's triangle because I like it better. I'm just going to build the triangle real quick. And I don't need to go past there. So my third row is 1, 3, 3, 1. And I'm gonna write them nice and spaced out so I can do our terms. So 5 r's first. I'm going to throw a 5r with all of them. And now the exponents for 5r, we're starting with 3. 3, 2, 1, 0. And now our negative 2 is our second term. There's no variable, just a constant. negative 2, negative 2, negative 2, negative 2, and we start with 0 and go up. 0, 1, 2, 3. And each of these 1, 3, 3, 1, all these guys are multiplied together, and so there's 1, 2, 3, 4 terms that get added together, or subtracted if it turns out negative. All right, we have 1 times 125, 5 cubed, times 1, anything to the 0 is 1, 125, and then I do the variable last, just r cubed. All right, here we have 3 times 5 squared is 25 times negative 2. 3 times 25 times 2 is 150, and it's negative. So minus 150, and our variable is r squared. And here we have 3 times 5 to the 1 is 5 times 4. Negative 2 squared means negative 2 times negative 2. So that's a positive. 3 times 5 times 4 is 60. Positive 60 r. And here we have 1 times 1 times negative 8. Negative 2 times negative 2 times negative 2 is negative 8. So minus 8. And we don't have a variable on that one. R to the 0 is 1. There we go. Pascal's triangle. And we have division. So I'll do one. It says synthetic, but I want to do one of each. So I'll do the first one. Remember, I just want to mention this. You can't use synthetic when what you're dividing by has a coefficient in front. So if there had been a number in front of the x, I could only use long division. So if that's on the final, keep that in mind. All right, so I'll do this top one in synthetic. We're dividing by x minus 3, so 3 goes in the little box. I think I wrote the box different for each class I taught. It doesn't matter. So I'm going to do it that way right now. So we have to put our coefficients in order, and that you have to pay attention if there's any missing terms. Our exponents go 3, 2, 1, 0, so we're not missing any. Negative 5, 3, negative 6, 8. And our first term just automatically comes down. And now we multiply, add, multiply, add, multiply, add. 3 times negative 5 is negative 15. 3 minus 15 or plus negative 15 is negative 12. 3 times negative 12 is negative 36. Negative 36 minus 6, or negative 6 minus 36 is negative 42. 3 times negative 42 is negative 3 times 42 is 42 times 3 is 126. And minus 8 is negative 118. Super big remainder, so that's okay. Your last one is always the remainder. So oftentimes, sometimes that'll come out to be 0. So if your last one is a 0, that just means there's no remainder. So you don't have to tag a plus whatever on the end. Now let's turn this back into a polynomial. I'm going to go look at my original. We're dividing x to the third by x. So that means our polynomial is going to start with x squared. X to the third over x is x squared. So our answer is negative 5x squared minus 12x minus 42. And now our remainder. Always put plus, and then whatever the remainder is, that's your numerator. Negative 118 over x minus 3. I hope I didn't make any little mistakes along the way. You guys will catch me if I did. Now long division. X minus 3 on the outside of our symbol here, and we've got a missing term. It's missing the x squared. So I'm going to fill that in with a 0. 25x to the third plus 0x squared minus 40x plus 6. All right. X times what is 25x to the third? 25x squared. Now multiply. 25x squared times x, 25x to the third. 25x squared times negative 3 is negative 75x squared. Draw the line, switch the signs, because we have to subtract. 0, 75x squared, bring down the minus 40x. These are going to be weird numbers too. Start again. X times what is 75x squared? Use green again. Plus 75x. Multiply. 75x times x is 75x squared. 75x times negative 3 is negative 225x. Draw the line, switch the signs. Add our columns. 0. 225 minus 40 is 185. 185x, and we still have another guy to bring down, plus 6. And I start again. X times what is 185x? A positive 185. Multiply. 185 times x, 185x. 185 times negative 3 is negative 555. I'm just going to do that again and make sure I typed it right. Yep. And draw the line, switch the signs. 0. 6 plus 555 is 561. There's nothing to bring back down, so that guy is our remainder. Final answer. I'm just going to leave it. I'm not going to rewrite it. I'm going to come up here and write my remainder. Plus 561 over x minus 3. And we are done. Woohoo! There's another page. Oh, whew. All right. I'm going to say a little prayer to the tech gods that this did record. And you guys have a good night.